All right, we're still in Unit 1. This is Chapter 5 still. We're going over some more practice problems to compare data, to be able to look at data, to understand with tables and frequencies and box plots and stem and leaf plots what we have and how it compares. So, here's another example. Researchers tracked a population of fruit flies, counting how many died each day for 171 days. And here are the 3 time plots offering different views of these data. One shows the number of flies alive on each day, one the number who died that day, and the third the mortality rate. So there's a living, and there's how many died, and then the mortality. All right, the fraction of the number alive who died. Okay. On the last day studied, the last 2 flies died for a mortality rate of 1. Okay. So that's just the rate, like 100% of them died. That's why they're saying that. So it's the rate of how many were left each time, taking a look at them. So it's kind of like this idea of seeing what happens. You have so many that are living, and then it tends to kind of fade down. And then over here, how many actually died each day. We had a bulk of them all die, and then it kind of put down as well. And then as you can see, if only 2 died, then the percentage rate wasn't very high, but then it kind of goes up towards the end because eventually they're all going to have to die at some point. So, on approximately what day did the most flies die? So if you're looking at this, you're looking for a peak or like a mode. You would just follow this over, and on what day during the first 100 days did the largest proportion of flies die? The largest proportion of flies die as well. So as we're looking at these, the most flies died around day 16. So if that's 5, it looks like somewhere around here, right? Day 16. All right, and if we look over here at day 16, those of you that know calculus, if you're looking at the peak of when it starts to change, that's basically also around day 16 when it would be its highest fluctuation and difference between them. So that also fits with this graph because that's the living one, and that's the peak when it happened as well. So you can see roughly about 60,000 flies died that day. Now the largest proportion of fruit flies died around day 65. All right, so when kids look at this graph, they're like, the largest proportion of them died around 65. Well, if they're looking here, you're not seeing much, right? That's day 60. You're like, well, how do I know about that? Or over here is day 65. How do I know about that? This one, largest proportion, is because around day 65, which would be somewhere around in here, I'm looking at close to 20% of that previous surviving population died. Okay, because it says the largest proportion of fruit flies died on or around that day. Whereas, yes, the proportion of them that skyrocketed is 100%. But trying to see the largest proportion of fruit flies that could have possibly died that day. And then around day 50, the number of fruit fly wasn't changing by very much day to day, right? By 50, everything started to kind of dwindle out. Everything started to dwindle out as well when you're looking at those. So different graphs, and the problem itself was a little confusing, looking mainly at these two to kind of get your answers for most of the questions anyway, if you look back here, because it wants to know the proportion in the first 100 days. So that's why when they said 100 days, there's 100 days. So that's roughly the highest spot in those 100 days of like a proportion of it happening. Obviously over here it's higher, so that's why they capped it at 100 days. Over here, here's a histogram of the assets of 79 companies chosen from Forbes' list of the nation's top corporations. What aspect of this distribution makes it difficult to summarize or discuss the center or spread? Makes it difficult because it's definitely skewed to the right drastically. So it's going to make it hard to find the center and the spread because trying to space out where these are and what it's between, even the spacing, 1, 2, 3, 4, 5. So what is this, about 500, 1,000? Like it's too far apart, so it's going to make it harder. And what would you suggest doing with this data? I would definitely suggest maybe trying to space it out a little more, but the distribution of assets of 79 companies chosen is definitely skewed heavily to the right, as a vast majority of companies have assets represented in the first bar, right? $0 to $10 billion, basically. And then after that, this makes the center almost impossible to find. I have no idea where that's going to be, but it's probably somewhere in here, if not in here, but that's it. So it makes it hard. And then re-expressing this data, for example, logs or square roots might help make the distribution more nearly symmetric than a meaningful distribution of center might be happening. So what they mean is, if I take my data, and if it's looking like I can't really get anything out of it, if I take all the numbers and I log them, or if I square root them, I might be able to see a pattern that comes from them, because I am technically shrinking every value down by the same fraction or same amount. So if I'm doing that, it's going to affect the means all the same, or the medians all the same. So it will affect everything the same, so I might be able to express my data a little better that way, which we'll get to that stuff when we start doing regression lines if you can't see patterns with it. I believe that is in the next unit, Unit 2. In this next one, students were asked how many songs they had in their digital music libraries, and here's their display again. And the point is, it's also skewed to the right, and there's a lot happening down here, so it makes it hard. So this is what aspects of this distribution make it difficult to summarize or discuss the spread. It's like the same setup as the last question, basically. The distribution of the number of songs students had in their digital library is extremely skewed to the right. That makes it difficult to determine the center, because I don't know what that exact number is going to be in between there where it is, since a majority of them are happening, especially in this first one. The typical number of songs in a library is probably in that first bar, but I don't know what that's going to be, because it's almost all in that first bar. And then again, the best way to help out with data that you can't really find where there might be like a center, because it's so badly skewed and the spacing is so awful, if you take logs and square roots of it, it could be very helpful. And here are the same data you saw before, all right, and us expressing it as square roots. And I believe this is going with the green one right here. Back a question. No, maybe not. But we were talking about taking the data in 37 and square rooting it. Now I know you don't know what 37 is, but we were talking about the number of companies. So let's see if I can find that one for you. Number of companies right here. Yep, there you go. Number of companies. So it was this data that I said, you know what, why don't we square root it? That was this first one. So here's what happened. We square rooted it, the assets. And now that I did that, now I can see a more, it's still skewed right. That didn't change. But now maybe I can find more of a middle out of it, right? Here's what would happen if I logged it. If I logged all the data to see what happens. Now it's looking more symmetric out of it, right? Now it's looking more symmetric. Easier for me to try to find that middle is what would happen. So it says, which expression would I prefer and why? And in the square root, what does the value 50 mean? So that is 1, 2, 3, 4, 5. So if I'm going up by trying to figure out where roughly 50 would fall, that wouldn't be halfway. So 5 spots, so 12.5 maybe. So I don't know, maybe it is around here-ish. That's probably where our mean, sorry, not mean, the mean would be down here. It's probably where the middle is. And we'll see. In the log expression, what does the value of 3 actually indicate about the company's assets when we're looking at this? Because this is more symmetric, right? So we want to take a look to see. The distribution of logarithm of assets is probably preferable because it is unimodal and pretty symmetric. So if you had to choose after you would log them or square root them, I would probably go with this one because it's a pretty good shape. The distribution of square root is skewed right with outliers, but it's still better than what it looked like before. We could get a better idea. And if the square root of the assets equals 50, then the company's assets would be approximately 2,500. We just work backwards. So if you find 50, if you want to figure out what that is, roughly, you would just square it to figure out what those original assets were. And then the same with log. If I take log 3, the log of whatever equals 3, then I would take it to a little 10, so it's closer to $1,000 million. But get the idea. So it's a lot of money is the point. But that's how you would rewrite them if you had to. So anyway, you can log or square root problems so you can get a better gist of what the middle might be. And in this case, because it is that way, I'd take a guess that this is probably the middle. You would take that number and then you would just log of something equals that and kind of solve it like an equation to figure out what it is, or the square root in this case over here to get the answers that are pretty similar. But with that in mind, we have finished up Chapter 5 with some practice problems for you. If you have any questions, let me know.